Welcome back. The last time we met, we were talking about independent versus dependent events, and today we're taking one small baby step forward and talking about conditional probability. Conditional probability is probability of dependent events. So you really already know how to do this, but we're going to go more in depth today to show you how it really operates. It's that given that A has already occurred, what's the probability of event B? We talked yesterday about how this means that the probability of A and B both occurring, is the probability of A times the probability of B given that A has already happened. So if we look at our first example, we have here event A being drawing a king from a deck of cards and event B drawing a king from a deck of cards. So we want to know what is the probability of drawing a king followed by a second king from a deck of 52 cards where there's no replacement. Because there's no replacement, that means that this is dependent. And so we need to start with the probability of a king and a king, which means that we're going to find the probability of drawing a king times the probability of a king given that a king has already occurred. And so one of the things we talked about in class in the last couple of days is that fact that there are 52 cards in a deck of cards. And there's one king in each suit. There are 4 suits. That means that there are 4 kings out of 52. So then, if we assume that when we draw that card out, we draw a king, there are now 51 cards left because we're not replacing, and 3 of them are now kings because we've already drawn one of the kings out. So now it's a matter of multiplying and simplifying. I don't want to multiply 52 times 51, but I know that 4 and 52 are both divisible by 4. That is 1 and 13. And 3 and 51 are both divisible by 3, which gives me 1 over 17. So now 1 times 1 is 1. 13 times 17 is 221. And my answer then is 1 over 221. So it's not a very good chance of that happening. For the second one, we have here the 2 number cubes, one's red and one's white, being rolled. And event A is rolling a 6 on the white cube. Event B is rolling a number on the red cube such that the sum of the 2 cubes is greater than 9. What is the probability of both events occurring? I want you to go ahead, solve this, do your best job with it, enter what you think is the probability into Edpuzzle, and then we can continue to see how we did. Taking a look at this problem, this is saying if we look at the probability of event A, so 6 white, and probability of event B being rolling a number on the red given a sum greater than 9. So that means that we want to know the probability of the 6 on the white times the probability of the number on red resulting in a sum greater than 9. And so the reason why this is dependent, even though we're rolling 2 separate number cubes, is because to get a sum of 9 or greater than 9 has to be dependent upon what you get on the white in the first place. So we know that to roll a 6 on the white is a 1 in 6 chance. Now on the second one, if we roll a 6, we're assuming that that 6 has already occurred. That means to get a sum greater than 9, I need to have a 4, a 5, or a 6 roll on the red. That means I have a 3 out of 6 chance for rolling a 4, 5, or a 6. So then I can say that this is 3 out of 36 when I multiply, which is also equal to a 1 in 12 chance that if I roll a 6 on the white, then I will roll a number on the red to give us a sum greater than 9. For our next example, we're going to take a look at Venn diagrams now and how they are used to find our conditional probability. So when we talk about these Venn diagrams, If A and B are events, then we're saying that the probability of A given B is going to take that intersection of A and B, which remember is this middle overlap, and we're going to divide it by the probability of B occurring, which remember means that we include that overlap because B is a full circle. So remembering intersection up here, and we've got our union here where it's all parts, and then if they're mutually exclusive, they don't have any relationship at all. So in our example, we have in a class of 25 students, 14 like pizza, 16 like iced coffee, 1 likes neither, and 6 like both. 1 student is randomly selected from the class. So remember, this U piece is a total of 25 students. And so it says 1 likes neither. That's an easy one to fill in, so I'm going to put the 1 out here. Obviously, 14 plus 16 is 30, so it's not just 14 and 16. It says 6 like both, so we'll put 6 in the middle. And it says 14 like pizza. And so that being the case, if 14 like pizza and 6 like both, that means 8 like just pizza. Because 14 minus 6 is 8. Now on the other hand, we got 16 that like iced coffee, but 6 of those people like iced coffee and pizza. So that means that 10 is going to like our coffee. And if we add these up, 10 plus 6 is 16, plus 8 is 24, plus 1 is 25. So we have everybody all good to go. So now that we have that, we want the probability that the student likes pizza. It doesn't say they can't also like iced coffee. So that means we need to take 8 plus 6 because pizza is going to be everything in this full circle. And that's over 25 total students. So that means that our probability of liking pizza is 14 out of 25. 14 out of 25. Now, the second piece is what is the probability that the student likes pizza given that they like iced coffee? This means that we're going to find the probability of the person liking pizza and iced coffee. We're going to divide it by the probability that they like iced coffee, which is, I got this from this formula right here. And so if we look here, the probability that they like pizza and coffee is going to be this piece here. So it's 6 out of the 25. Now the probability that they like just coffee is going to be all of this here, which means that we're going to have the 10 plus the 6 out of the 25. So that 10 plus 6 is going to be 16 out of 25. So then that means if we put that into our formula, that's going to be 6 out of 25 divided by 16 out of 25. Now do we remember from way back when that dividing fractions is the same thing as multiplying by the reciprocal? So 6 over 25, and that's going to be times 25 over 16. The 25's cancel, leaving us with 6 over 16, which simplifies to 3/8. I want you to take that knowledge now, and I want you to try this problem on your own. I have 100 math students, 70 of which are taking Algebra 2, 50 of which are taking chemistry. 30 students taking both Algebra 2 and chemistry. Choosing a student at random, what is that N is taking Algebra 2, what is the probability that he or she is taking chemistry? Give this a shot, enter your answer, and then we'll go ahead and check it. All right, to start off, it says that we have 100 math students. That means total have to be in the box 100. It says 30 students are taking both Algebra 2 and chemistry, and 70 are taking Algebra 2, so if 30 of those 70 are taking Algebra 2 and chemistry, that means that 40 are taking Algebra 2 but not chemistry. And if 50 are taking chemistry and 30 of those are taking algebra 2 as well, that means that I have 20 over here. So if I add up 40 plus 30 plus 20, I get 90, which means 10 of my students are not taking algebra 2 or chemistry. Now that we have that, we need to know the probability that given the person is taking Alg 2, that they are also taking chemistry if I select them at random. Breaking that down, that's going to be the probability of taking chemistry and Alg 2. And we're going to divide that by the probability that of them taking Alg 2, because Alg 2 is what we are assuming has already occurred. So looking at this, the probability of chemistry and Alg 2 occurring is this right here, which is 30 out of the 100 students. The probability for Alg is going to be all of this in the big circle. So we have here 40 plus 30 over 100. So that means 70 out of 100 are taking Alg 2. And so when we put that into our formula, that's going to be 30 out of 100 divided by 70 out of 100. So keep flip change, 30 out of 100 times 100 over 70. The hundreds cancel. That leaves us with 30 over 70, which divides by 10, to get a probability that 3 out of every 7 students will have the probability that they are taking chemistry, given that they are already taking Alg 2. Your job now is to go ahead and give these 2 U-try problems a shot and answer those questions. Enter them into Edpuzzle and bring your questions with you to class tomorrow.